All right, we have kind of a plain integral on the board. It's just square root 1 plus 5x over x. And I just want to do some straightforward things on it. It's nice to get practice with integrals. Even sometimes with the plain stuff, it can get pretty complicated. So what I want to do is, let's do a u sub for the whole denominator here. So we'll do u equal to square root 1 plus 5x. And then from here, I don't really want to differentiate this because it could get messy. So let's solve for x first. So if we square both sides, we have 1 plus 5x equals, nope, there's no y, we'll do it u squared minus 1. That's just, well, sorry, we've got u squared. I need to subtract off the minus 1 here. And then we got u squared minus 1 over there. And then to isolate x, let's just divide by 5. And so we have x equals, we'll write it like this, 1/5 u squared minus 1. Then from here, let's get our dx value. Take a derivative here. What's going to happen? We have dx constant out front. That part's just going to be 2u du. Okay, I don't need this, right? So we'll clean it up and we'll go ahead and substitute the whole numerator again. This is u. So what's going to happen? We need a marker. So what we get is it's just going to be u. X is this thing. Let's take the 5th out as a constant, but it's in the denominator, so we flip it, bring a 5 out front, and we're going to have u squared minus 1. dx is this. Let's see, it's going to be 2/5 u du. But now we can cancel 5s here and here. We can multiply this u in here and get a u squared term. And then we can take this 2, bring it out front as a constant. Let me clean it up and see what we have. So we just have a 2 over here. But now here, I think the way to go is let's create a minus 1. So then this integral is just going to be 1 if we do it like that. Get this, the du's floating way out there, so we bring that back. Now we don't want to change it, so I'll add a plus 1. But I want to break that off into a separate integral. So when we do that, we'll distribute it and we'll have the 2 out front. The second integral is just going to be 1 over u squared minus 1 du. Now again, this thing here is just a 1, so we integrate the first part, we get 2u. That thing, that's going to be a common integral. We'll use a formula on that. The integral of 1 over u squared minus 1, you could do it a couple different ways. You could express it as tanh, or we could use natural log. Let's do it. I was going to say I'm trying to match MIT solution, but that's not the case here. But we're going to use the natural log version anyway. So the formula for that is going to be 1/2 natural log u minus 1 over u plus 1, and we need absolute value on it. And then all that's left, we just need to back substitute in order to finish it off, bringing our u value back into it. So putting it all together, for my final solution, we have 2 square root 1 plus 5x. Here, that's going to cancel out, and we're going to have just plus natural log square root 1 plus 5x minus 1 over square root 1 plus 5x plus 1. This is a good reason why you might want to use tanh, because it's kind of less messy than this, but we'll leave it. Add a plus c, and that's it. Okay, so there you go. Pretty straightforward stuff, pretty quick and easy, and we'll call it good. So that's it for today. Thanks everyone for watching. Have a good day.